Okay, so we have here, first of all, the notation of vector. Just like in chapter 1, when we learn equations of lines and planes, we already learn vector indirectly. Okay, we already learned vector indirectly in chapter 1, topic of equation lines and planes. Okay, but now we are going to learn about vector in details. All right, so let's say we have a vector of r with respect to t. A common notation for vector, of course, we have a function of xti. This is for i's component. You have tilde, means direction. Okay, means vector, tilde bawah ni. This is called as tilde. Okay, you should have that notation. And then plus ytj, this is for j component or j direction. And then plus ztk. Okay, this is for k direction. So we will have all the components with tilde, okay? Means vector. Another notation, we also can write vector as RT equals to sharp bracket, or some mathematician call this as a cube bracket, okay? I don't want, saya suka panggil sharp sebab it just memang sharp kan, dia ada bucu tu. So sharp bracket also represents vector where we can put xt, yt, and zt. Okay, so next, we are going to learn about domain. Okay, domain. You already learned about domain previously in secondary school, right? Have you learned about domain previously?
Yes.
Okay, so we're just gonna recall back what you already learned before, okay, in your secondary school. So I will give you a very simple question first. Okay, let's say example. Find the domain of the vector function okay, let's say RT equals to 3t sine 2t and then exponent 4t, like this. Okay, when we talk about domain of vector function, it means that we need to combine the domain for all of these three components, 1, 2, 3, component for I, J, and K. Okay, so what we should do is we need to identify the domain for each component. So first, okay, solution. Let's say domain of 3t. Okay, guys. So 3t is the group of polynomial. Okay, 3t is actually categorized as polynomial group. Okay, so the domain for polynomial is just, okay, we have a notation like this, t such that t element of real number. Okay, this is actually one method to write a domain, or you also can write this way, element of real number. Okay, t element of real number, element of real number. Itu maksud dia. Okay, ini maksud dia. Ni. Ni maksud dia ni. T element of real number. Okay, or another way of notation for domain, we can also write this way. Since t element of real number means t can be any values, negative or positive, from negative infinity up to infinity. So we can write the domain as this. Okay, negative infinity until infinity. Okay, so either one lah. Kalau you comfortable with this notation, you can write this way. This one. Okay, kalau you comfortable dengan bracket, you can write this way. It's up to you. Okay, you can move. You can use either, and then domain of sine 2t. Okay, guys. What's the domain of trigonometry function? Right now we have trigo. What is the domain for trigo?
Real number.
Yes, also a real number, the same as polynomial. Yes, okay. So again, the domain of trigonometry also from negative infinity until infinity. Because, okay guys, apa maksud domain ni sebenarnya? Domain ni actually, okay, domain ni adalah any numbers that suits the function. Okay, any numbers that can be plugged into the function so that the function will be valid. Okay, apa-apa nilai yang kita boleh masukkan dalam function tu supaya function tu nilai dia valid. Okay, so dalam trigonometric function, let's say kalau you ada calculator sekarang. You have calculator with you now?
Ada.
Guys,
Ada.
ada. Ngantuk lagi ke? Minum makan biskut sambil online kelas ni, sambil tulis ni. Okay, if you use your calculator, you can key in sine 1000 for example. Kalau you klik sine 1000, dia still ada nilai. And then you try cos negative 2000, you still can get a values, right? So that's what I mean by valid tak valid tu. Okay, however, okay, cuba you try tekan, you try ln, and then you try tekan ln 0. Keluar tak jawapan ln 0?
Ada.
Tak
Tak
ada
ada.
math error kan? Math
Ya.
error. Okay, yes. So bermaksud untuk function ln, nilai t tak boleh jadi 0. Okay? Okay, so itu maksud domain. Maksudnya nilai-nilai yang possible yang kita boleh masukkan dalam function so that the function is valid. Okay? So in this case, for sine 2t, for trigonometric function, the domain is all real number. So we can have from negative infinity up to infinity, which means that for trigonometric function, any numbers of t can be plugged into that function. Okay, next. Function for exponential, domain of exponent 40. Exponential, exponent, okay, exponent negative, let's say exponent negative 100. Wujud tak kalau tekan calculator? Keluar error tak? Shift exponent negative 100. You still can get answer, right?
Yes.
Okay, so
Yeah.
which means that for exponential function also from negative infinity up to infinity. Okay, dia tak ada restriction. Dia tak ada restriction. So, yes.
Exponential tu tekan yang mana ke dalam kalkulator?
Tekan yang mana dalam calculator? Dia ada E tu. Ada tak E kat calculator you all?
ENG ke?
ENG, bukan sayang. Dia ada E.
Dekat lon tadi.
Dekat long tak. Dia depends on calculator actually. Sekejap macam mana saya nak sekejap
Lon.
Tekan shift lon.
Shift lon.
Oh.
Ikutlah kalkulator awak. Kalau kalkulator awak kena shift lon kena shift lon lah. Kalau kalkulator yang ada E dah tu, tekan E saja.
Shift lon dapat 10. Betul lah? Ke
Tak.
yang shift in?
Awak shift E, shift, okay. Bila shift lon tu keluar E tak?
Ada.
Ada.
Shift in. Okay,
So-
thank you.
LN tu lon. Yes. Aduh, mencabar sebenarnya kelas online ni. Susah nak demonstrate. Okay. So now, guys, okay, we have these three functions. So next you have to combine all of these three. So negative infinity up to infinity, intersect with negative infinity up to infinity, intersect with negative infinity up to infinity. Of course lah, dan memang ada negative infinity sampai infinity kan. So the answer is negative infinity until infinity. That's it, that's the answer. Okay, ni yang paling mudah saya bagi soalan ni. Okay, example number 2. 5 find the following. Find the domain of, let's say you have a function. Okay, right now I'm going to give you another type of function. Let's say we have a fraction like this. Okay, and then square root of t plus 5 and then 10. Okay, now we need to find domain for each component. So domain, okay, solution. Domain of 1 over t minus 3. Okay guys, 1 over 0 equals to what? Can you use your calculator? Cuba gunakan calculator, 1 bahagi kosong, wujud tak?
Error.
Okay, there's error, right? Yes, which means that in this case, the denominator cannot be equals to 0. Okay, pembawah tak boleh jadi 0. Okay, so cannot be 0. Therefore, the domain, okay, let's say now, okay, t minus 3 cannot be equals to 0. Therefore, t cannot be equals to 3. Okay, maksudnya t tak boleh sama dengan 3. Kalau t equals to 3, 3 minus 3, we get 0. So 1 and over 0 is undefined. Okay, undefined. Tak boleh. So the domain for this type of function would be like this. Okay, set t such that t element of real number. However, t cannot be equals to 3. Macam tu. Ataupun, or another notation is like this. From negative infinity until 3, okay, union 3 until infinity. Macam tu. Okay. Alright. Curve bracket ni. Okay guys, apa maksud curve bracket ni? Kurungan. Curve bracket. Ni maksudnya tak termasuk, not included. Not include. Okay. Kalau dia not sharp bracket, square bracket. Kalau macam gini, square bracket means include, termasuk. Okay. So dalam case ni, kita buat curve bracket ni because 3 tu does not include. Okay. Kalau 3 tu termasuk, dia tak valid benda ni. Okay. So t can be any numbers except 3. Okay. Maksudnya untuk domain bagi function kita ni, 1 over t minus 3 ni, t can be any numbers, okay, element of real number, apa-apa saja nombor, negatif pun boleh, kecuali 3 je tak boleh. So that's why the domain should be like this, or you can write your domain like this. Okay, baru first component. Okay, next. Domain of the second component, square root t plus 5 tu. Is there any restriction for this? Ada tak any t yang tak valid dalam function ni? What does it mean by square root, guys?
T equal to 5. Dia tak ada negatif.
Dia tak ada negatif, yes, good. Dia tak ada negatif, okay, yes, dia tak ada negatif. T boleh jadi negatif 5 tak tapi?
Boleh.
Boleh kan? Okay, cuba tukar calculator. Square root, you letak 0. Wujud tak nilai?
0.
Equals to 0, yes. So it's valid. So in this case, guys, what happened? Dalam square root sign ni, dia must be greater or equals to 0. Okay, something like this. So now, t plus 5 must be greater or equals to 0. Sebab kalau nombor negatif dalam square root, dia tak wujud. We cannot have, let's say, negative 1. Dia tak wujud. Negative 1 is a complex number equivalent to I. Okay, dia bukan nombor real, dia tak real. So, dia tak boleh negatif dalam ni. Dalam square root sign tak boleh negatif. So T plus 5 must be greater or equals to 0. Therefore T, sekejap, sorry. Color black. Therefore T must be greater or equals to 5. You pindah sebelah kanan, you will get negative 5. Okay? So in other way, we also can write the domain as this. Okay, sekarang ni ada simbol equal sign tau. Maksud equal sign ni dia termasuk negatif 5. Because when T equals to negative 5, okay, kalau you masukkan negative 5 dalam ni, misal kata T equals to negative 5, negative 5 plus 5 square root, we get 0, right? Still valid. Tapi kalau kita masukkan T equals to negative 7, for example, negative 7 plus 5, we will get negative 2, square root of. This is not valid. Okay, so T must be greater or equals to negative 5. Ni maksud saya equal sign ni yang ni. Yang kat bawah ni, ni equal sign ni. Greater than and equals to negative 5. So dalam kes kita ni, kita nak buat dalam bentuk bracket sekarang ni. Curve bracket ke square bracket? The minimum values of T.
Square bracket.
Square bracket, yes, well done. Square bracket. So it's include negative 5 until infinity, like this. Okay, understand guys? The concept of domain. So bermaksud dia daripada negatif.
Dia nak tanya.
Ya, boleh. Tanya.
Yang atas tadi, yang infinity tu, kenapa kita tak buat square bracket
Sebab dia tak termasuk. Kalau kita buat square bracket ni bermaksud termasuk 3.
Yang bahagiannya infinity. Kenapa tak buat square bracket lepas tu tutup dengan curve bracket?
Tak boleh. Dia macam ni. Maksud ni, okey, saya pakai marker pen pula, saya pakai warna merah, warna pink ni. Maksud ni ialah you boleh jadi negatif infinity sampai 2.999 pun. Okey, ni yang sebelah kiri. Okey, ni faham 2.999 Boleh guys? Ni yang sebelah kiri. Saya explain yang dulu. Okey, yang ni pula apa maksud dia? Kenapa dia kena open juga bracket, dia bukan close bracket? Sebab dia tak termasuk 3. Which means that it can be from 3.001 until infinity. Macam tu. Tapi dia tak boleh 3. Kalau you buat close bracket 3, ini termasuk 3. Tak boleh. Okay,
No, bukan yang saya bukan masukkan yang sebelah 3, sebelah infinity.
Sebelah infinity? So, infinity, okay guys, macam ni. Infinity, kenapa dia close bracket? Macam ni. Kenapa maksud awak, kenapa dia tak negative infinity macam tu? Dan kenapa dia tak infinity macam ni? Okay, good question. Okay, got the point. Okay, kenapa guys? Because infinity is an unknown number. It's very large number. We don't know the exact values of infinity. Kita tak tahu. That's why kita kena buat open bracket. Kita kena buat curve bracket. So in terms of notation, you tak boleh letak salah ni. Dari segi matematik penulisan ni salah. We cannot write like this because we don't know the exact amount of infinity. Kita tak tahu benda tu adalah very large, but we don't know how large. Okay, so that's why we cannot use a close bracket. Okay, good question. Alright. Because another way guys, saya explain juga kenapa tak boleh close bracket tu, sebab cara infinity dia ada anak panah sini guys. Okay, tapi anak panah tu sampai mana kita tak tahu. We just put up to infinity, macam tu je. That's why dia close bracket infinity. And then kalau negative infinity pun sama, dia ada anak panah ke kiri. Okay, ke kiri, and then we need to use this bracket negative infinity. Dia tak termasuk the I mean it must be open. Dia sampai mana-mana kita tak tahu. Okay, is that clear? Understand?
Yeah.
Understand?
Okay, good. So now kita kena combine ni, ketiga-tiga ni. Yang tadi senang lah, soalan 1 combine benda yang sama. Okay, however, for the second question, we have different values, different domain. Yang tadi mula-mula tadi mana? Ni, hijau ni. Ada satu lagi. Sorry guys, ada satu lagi tinggal. Domain of 10. domain of 10. Oh, mana ni pula lah, taklah. Okay. 10 ni tergolong dalam apa sebenarnya? Domain of 10, there is no t, right? It's a constant. Constant ni also part of polynomial. So again, the values is t can be any numbers.
Real number.
Yes, real number, yes. So from negative infinity up to infinity. So we don't have problem for that because it's just a constant. You letaklah t berapa pun, negatif 1000 ke, negatif 2000 ke, positif 1000 ke, dia tetap 10 kat situ. So that's why dia adalah negative infinity up to infinity. Okay, let's say we have a number line, okay, negative infinity up to infinity here. Let's say we have 3, negative 5. Okay, so here should be negative 5. Negative 5 and here is 3. Okay, so domain of, okay, let's say the first one from negative infinity, okay, this one, t element of real number, but t not equals to 3, it should be like this. Okay, saya buat bulatan tu without coloring the circle, which means not include So until here, okay? And then next, we have t must be greater or equals to negative 5. T from negative 5 up to infinity. Okay, so from negative 5 here up to infinity. Ini beza there's the difference. So this symbol means not include. Okay, not include. And then this symbol means include. Okay, and then the last one from negative infinity up to infinity. Okay, so semua sekali lah. Alright, so basically the region, the bounded region, the intersection should be this, right? These two. So we will have the domain of RT. RT ni function kita tadi lah. Ni RT. Soalan asal kita. RT. A combination of all of these functions should be equals to open the bracket like this such that t element of real number, but t must be greater or equals to negative 5 and then t cannot be equals to 3. Dia macam ni. Or you also can write your domain like this from negative 5 until 3, close bracket, union from 3 up to infinity. So both are correct. Either one lah. Kalau you suka macam ni, tulis jawapan macam ni. Kalau you suka bracket, you tulis macam ni. Okay, both are correct. Okay, that's it. Okay, next, third question. Question number 3. Find the domain of, okay, let's say we have RT equals to square root of 8 minus t, and then we have ln t plus 3. And then let's say exponent 10t. Macam ni soalan dia. So solution. Domain of square root 8 minus t. Okay guys, what's the domain? First of all, we know that this is square root sign, so must be greater than 0, right? So we will have 8 minus t must be greater or equals to 0. So negative t must be greater or equals to negative 8. Okay, what happened when we have negative sign? Coefficient of t is negative. What happened? What we should do? Yes, we need to change this. The inequality sign. Okay, so we need to change the inequality sign. So t must be less than or equals to 8. Okay, or we can have the domain of square root 8 minus t should be open ke close bracket ni, macam mana ni? How to write it in bracket? What is the lowest values of t?
Negative infinity.
Yes, negative infinity until 8, and then with square bracket. Okay, square bracket. So next, domain of ln t plus 3. Okay, domain of ln t plus 3. We have, okay, like previously I mentioned to you, we don't have t inside ln. Ln cannot be, ln 0 does not exist. Okay, ln 0 does not exist. Ln 0 does not exist. Okay, so which means that the value inside here must be greater than 0, but cannot be equals to 0. So we just have not equals, greater than 0. Okay, without the equality sign. Kalau yang atas tadi, ni dia ada equality sign. However, for ln, we don't have equality. We just have greater than 0 because ln 0 does not exist. Okay, so how to do this? T plus 3 should be greater than 0. No equal sign dia tak ada equal sign. Dia adalah greater than 0 sahaja. Dia berbeza dengan yang atas tadi. Atas tadi kita ada equal sign. Ni. However, right now, for ln, we just have inequality sahaja without the equal sign. So t plus 3 greater than 0. Therefore, t greater than negative 3. So how do we put the domain in bracket? Open ke close bracket now, guys?
Open.
Open, yes. From negative 3 until infinity like this. Okay, kenapa open? Sebab dia lebih besar daripada negatif 3, dia tak termasuk 3. Kalau tadi dia close 8, yang 8 ni, kenapa dia square bracket? Sebab dia termasuk 8, dia ada equal sign. Yang bawah ni dia tak ada. So that's why dia open bracket je, dia curve bracket. Okay. So now let's combine all of this. Okay, before saya terlupa yang bawah sekali ni, yang exponent 10t. So domain of exponent 10t, 10t should be from negative infinity until infinity. Okay, so we need to combine this. Negative infinity 8 intersect with negative 3 up to infinity, intersect with negative infinity up to infinity is equals to, okay, again, let's say I have this oh patutlah saya punya pen dah longgar. Sekejap So let's say we have this. This is from negative infinity up to infinity. Okay, domain of the first one, negative infinity up to 8. So let's say here we have 8. And then let's say here we have negative 3. Okay, up to 8. So sini dia bulat, dihitamkan. Sampai negative infinity, macam tu nak panah dia. Next, we have this negative 3. Negative 3 until infinity. So from negative 3, open the bracket until infinity like this. And then the last one from negative infinity up to infinity. So of course we have this. So where is the intersection region, intersection domain? It should be here, right? Kawasan tu sahaja. So which means that therefore the domain is, therefore the domain of RT is from open ke close, the minimum one?
Open.
Open, yes. 3, negative 3 until 8. Ni dia punya jawapan. Last sekali. Okay, sebab kita nak yang intersect sahaja. Ketiga-tiga garisan tu ada. Intersect dia kat situ lah. Okay, that's it. Did you understand, guys? Dalam quiz masuk ni soalan komen ni. Understand?
Yes.
Okay, next. Kita tengok ni lah. Kan tak habis syllabus kan. Okay, look at the exercise 2.1. What else we are going to learn in 2.1? Oh, the cross product, dot product. Okay, graph sketching. Okay, jom kita buat soalan ni. Question number 2. Let's say we do sketch parametric curve. Okay, let's say question number 1. A. The simplest one first, copy. Exercise 2.1. Question number 2. Okay, how do we sketch this? Okay guys, actually this is your X. And this is your Y, right? So X equals to 2 minus T and then Y equals to 3 plus T. Okay, so it's just like parametric equation in chapter 1. Okay, parametric equation in chapter 1. We have, okay, from X, we have X equals to 2 minus T. Therefore, T equals to 2 minus X. Okay, so substitute in Y. We have Y equals to 3 plus 2 minus X. Okay, so gantikan T. T tadi kan, 3 plus T. So T is 2 minus X. We will get Y equals to 5 minus X. So by using intercept form, as usual, intercept form, we will have Y plus X equals to 5. So Y over 5 plus X over 5 equals to 1, like that. Okay, so we can simply sketch the graph. Okay, right now since we have only X and Y, so just 2D lah graph tu. Okay, so here we have X, we have Y, so 5 and 5. So let's say 5. 5 here and 5 here. So this is the line. Okay, this is the parametric curve. All right, now other way is like this. From here, okay guys, from here, this is the parametric equations of line, kan? Chapter 1. Ingat lagi tak? Equation of line. Okay, so P naught is actually 2 and 3. Okay, what is V in this equation? What is V? Parallel vector. From this equation. Dah lupa ke guys? Baru je buat quiz last 2 weeks.
Negative 1, 1.
Yes, good. Negative 1 and 1. So negative 1 and 1. So now guys, actually, okay, concept of straight line, it should be passing through P naught and then parallel to vector V, right? Concept of a straight line passing through P naught and parallel to V. Parallel to V. Itu konsep dia kan untuk equation of line. Passing through P naught and parallel to V. So if we plot V, I will use blue color. V, negative 1 and 1. So negative 1 and 1, we start from the origin here. Okay, tengok pada part C ni, graph ni. So we move to negative 1, one step, and then we go up one step. So we have this. Okay, so this is the vector of this line should be this. Okay, parallel to this vector. Betul lah tu. Okay, jawapan biasanya dia nak yang hitam ni je, yang the black color ni je. Okay, don't worry lah. So next, that's for the, okay, now B also straight line. Let's do question C. This question. Question C. Sama macam chapter 1 juga guys, konsep dia sama je. Okay, here this is our X and this is our Y. Okay, so we will have X equals to square root T, therefore T equals to X squared. Thus, substitute in Y equals to 1 minus T, so Y equals to 1 minus X squared. Okay, so now if you sketch the graph, you will just get X and Y. So where's the location? Up, down, right or left? Atas, bawah, kiri, kanan ni guys.
Atas ke bawah.
Okay, the atas and the shift 1. Okay, so it's something looks like this. Alright, but we have square root sign, so X should be just this one lah. Dia macam ni sebenarnya. Here is 1, right here is 1. However, X must be always positive, so we erase this part. We erase this part, so ni tak ada. Okay, orientation dia. The orientation should be 1 minus T. So, ni increase lah. This one decrease. So, downward, right? So, that's the orientation should be downward. That's it. So, habislah itu je. Simple je guys. Sama macam chapter 1. Graph dia. Okay, next. Question. How about question D? Question D bentuk apa guys? Ni. Just answer me. Question D bentuk apa?
Bulat.
Circle or ellipse?
Ellipse.
Ellipse. Okay, good. This is an ellipse. Okay, ellipse. How about this? Circle or ellipse?
Circle.
Circle, yes, circle. But I think this is half circle because of this. Dia sama macam parametric equations lah guys. Sama je. Okay, let's do, okay. Ni circle tapi sebab dia bounding daripada T from 0 until pi over 2. Okay, so this must be only half circle. Alright, how about this? Ni bentuk apa ni? Ni, jom kita buat nombor 3. F ni. Ni baru. You all belum belajar lagi ni. Let me explain to you about this. Copy. Okay. Alright, question 2F. Okay, this is called as circular helix. Circular helix. Okay. As usual, guys, this is your X, this is your Y, and this is your Z. Okay, kalau tak ada Z ni, kita akan dapat bentuk apa? Circle kan? If you don't have Z, then we can get a circle, right? Okay, now T is equals to Z, which means that T is your height, ketinggian. Okay, so circular helix is something like this. Saya lukis dulu terus graph dia guys. Nanti saya akan explain kenapa kita dapat macam tu. Okay, we will have this curve. This is X, Y, and Z. Okay, right now kita ada 3 lah. So circular helix will be like this. Dia membentuk seperti spring. Spring yang bulatan. Okay. Wow. How we get this? Because, okay. Tadi kita ada RT equals to 3 cos T 3 sine t and t, right? Okay, let's say we have 0. So substitute. Okay, when t equals to 0, so substitute 0. Okay, t equals to 0. We have 3 cos 0 is 3. 3 sin 0 should be 0. 0, 0 lah. T equals to 0. So, first of all guys, dia vektor kita yang pertama, function vector kita kat sini. This is 300. Okay? That's the coordinate of 300. Next, when t equals to, let's say, pi over 2. Okay, pi over 2. Guys, can you give me pi over 2 is equivalent to what? In decimal. What is pi over 2? Pi over 2 sama dengan apa ke guys? Dalam bentuk perpuluhan.
1.57.
1.5.
Yes, 1.57. Okay, 1.57. So now, if you substitute t equals to pi over 2, you will get r pi over 2. We will have 3 cos pi over 2 is 0. 3 sin pi over 2 is 1. So times 3 lah. And then here is pi over 2. Okay guys, pi over 2 is actually 1.57. Okay, 1.57 means your height. Right now dia naik sikit. Okay, the height is getting higher. Okay, naik sikit tapi dia berada pada position 0, 3. X equals to 0 and Y equals to 3. So it should be located here. Okay, let's say here is pi over 2. Is 1.57. Macam tu, dia tinggi sikit. Okay, and this is actually 0, 3 and pi over 2. Okay, when you keep increasing, okay guys, when you keep increasing, let's say t equals to pi. For example, you naik atas lagi, r pi is equals to 3 cos pi is negative 3, 3 sin pi is 0, negative pi. Negative pi pula pi. Okay, so pi maksudnya dia tinggi sikit lagi. Okay, pi, let's say pi here. Ke pen biru. Let's say pi is here. So you will have this position. Okay, 3, 0, and then pi. It's getting higher and higher and higher. Dia akan membentuk bulatan. Last kali dia akan jadi spring lah. Understand the concept? Okay, so you will get a circular helix for this type of equation. Circular helix nama dia. Kalau the values are not the same, it will be elliptical helix. Okay, but now the values are the same, so we can get circular helix. Understand, guys?
Yes.
Yes.
Okay, good, well done. If I change this, let's say, kalaulah saya tukar, let's say RT equals to, let's say T kat sini, and then 4 sin T, 4 cos T. Circular helix ni akan memanjang ke mana? Dia akan parallel sepanjang paksi apa guys? Kalau untuk soalan ni. X. Okay, good, well done. It depends on the T. Okay, so it depends on the T actually. Kalau T tu berada pada paksi X, maksudnya dia akan sepanjang paksi X lah, ke depan ke belakang lah. Okay, and then kalau T tu duduk dekat Y, pada paksi Y lah. Okay, something like that. So we settle already on that part. Okay, question number 3, find the vector equation and parametric equation of the line. Ni sama lah. Cari vektor, so Q minus P. Sama macam chapter 1. Dia tak ada apa lah ni, saya tak nak tunjuk lah. Dia just very simple. And then your P naught should be, cari P naught. Your P naught should be this one lah. Okay. Alright, now question number 4. T squared. Alright. I think plus, tak ada apa lah guys. T squared. Kalau addition plus ft plus gt means you just tambah by component. Okay. But if you have something like this, Okay, kita buat sikitlah soalan ni. Copy. Paste. Undo. Let me check this. Okay. Jom kita buat soalan FT GT 41 F plus G. Okay, so F plus G means, okay, let's say F T is equals to T squared 2T and cos T. Okay, and then your GT is T squared plus 5. Okay, like this. So F plus G is just notation, guys. Actually, sama lah dengan FT plus GT lah, of course. Okay, so it's very simple. You tambah aja T squared plus T. So this is for X component, I component, T squared plus T, and then 2T plus T squared, and then cos T plus 5. Okay, that's it. That's the answer. Very simple addition, tak ada apalah. Okay, and then now question 2. Question 2, we have sin T FT. Sin T FT. Okay, so what you should do now is you have to multiply sin T with, okay, darab. Saya tak nak ni lah, nanti you all confused pula. Terus tulis macam ni lah. Okay, didarabkan dengan vektor F. So T squared 2T cos T. So multiply, you will get T squared sin T, and then 2T sin T, and then sin T cos T lah, ataupun cos T sin T, either one. So you just darab masuk saja. Okay, you darab by component wise. Okay, that's it. And then F cross G, cross product ni sama macam chapter 1 juga, cross product. Number 3, F cross G. So again you have I, J and K. So don't forget here plus, minus, plus. So for F we have T squared 2T cos T. T squared 2T cos T. And then we have T squared. Oh, saya tersilap ni. Dia bukan plus, dia koma. T squared 5. T squared 5. Okay, jom kita buat. So now you close the first column. Right now you are closing the second and third column. 2T darab 5 tolak T squared cos T. Okay, so we will have 2T times 5 minus T squared times cos T. This is for I component, minus J, sebab J ni negative kan. So we have close the second column, we are closing the first and third column, so we will get 5T squared minus T cos T, J, and then plus K, close the third column, so we are closing the first and second column, so we have T squared times T squared. Ni guys, T squared times T squared, and then minus T times 2T. So we have T to the power of 4 minus 2T squared. This is for K direction. Okay, so we will have 10T minus T squared cos T. This is for I, minus 5T squared minus T cos Tj, and then plus T to the power of 4 minus 2T squared. Okay, all right. Next, okay, dot product. Dot product. Okay, guys, what's the difference between dot product and cross product? What's the difference, guys? Can you answer me? Come on, my brilliant student. Apa beza dia?
Multiply I and I. Okay,
Sorry,
different.
pardon?
You will multiply the same vectors.
Okay, kalau ni cross product means the answer will be in vector. Okay, this is a vector. However, for dot product, we just get a scalar. No more vector ijk. Okay, so that's the difference cross product dengan dot product. Okay, good answer. So now, let's do f dot g. Jauh sangat ni, saya salih balik lah. F dot g should be like this. F dot g equals to ni you darab by component wise lah, and then you tambah, so tak ada vector sharp bracket dah lah. So t squared times t. Okay guys, t squared times t plus. Okay, so dia dah tak ada ijk dah. Kalau you letak ijk, your 1 mark will be deducted. Okay, satu markah tolak. So dalam dot product dia dah tak ada ijk, dia tak ada sharp bracket, dia bukan vector. Dia adalah nilai skala. And then next, we have 2t times t squared. So 2t times t squared plus last one, cos t plus 5. Okay, so we have cos t plus 5 multiplied by 5, so 5 cos t. So we can write this t cubed plus 2t cubed plus 5 cos t, or this is 2 tambah 1, so 3t cubed plus 5 cos t. Okay, that's it. Okay, so that's chapter 1 punya material. Okay guys, the rest question tu is very simple lah, just tolak je lah macam biasa dia tak ada apa lah. Minus 2ft maksudnya you multiply by 2, and then 3 multiply by g, so semua 3 lah. This one pun sama. Okay, this one, okay, how about this one? You have to cross product first. Okay, solve the process in the bracket first. Do this first, followed by dot product. Okay, so next, subtopic 2.2, derivatives and integrals. Okay, 2.2 is about derivatives and integrals of vector function. 2.2, derivatives and integral vector function. Okay, let's go for derivative first. Okay, kita tengok derivative dulu. I give you one very simple example. Okay, derivative. Okay, before I go for example, let's look at the rules or theorem. Ini definition lah by the limit kan. Tak ada apa lah. Okay, differentiate. Sama juga, kita akan differentiate by component wise. Okay, component I, J and K. Alright, tangent line and vector tangent vector. Okay, nanti kita akan go for tangent line and tangent vector through examples lah. Kita nak go for this first, rules ni. Guys, don't worry, don't bother about this. Okay, you tak perlu hafal pun benda ni. Okay, no need for you to memorize this. You just solve the values, the process in the bracket first. Okay, you just solve the process in the bracket first, and then baru you differentiate. Sama jugalah for the rest of this. Selesaikan dalam bracket dulu, baru you differentiate. You tak perlu hafal pun yang kat belakang ni. No need for you to memorize. Okay, because you will get the same answer. No need for you to get stressed with all these formulas. No, we just solve the process in bracket, lepas tu baru you differentiate. Sama juga yang bawah ni, number 5. Solve dalam bracket dulu, cross product dulu, baru differentiate. Okay, so next. I give you one simple example of derivative. Okay, example. Kita bagi soalan yang ada product rule lah. So find the derivatives of the vector function. Let's say RT equals to 4t sine t, and then we have 5t squared exponent 3t, and then we have 5t, 5 lagi. 4, 5, 6 6 exponent, let's say exponent 10t, macam itu. Okay, so find the derivative. What does it mean by derivative, guys? Apa maksud derivative? We have to
Differentiate.
yes, we have to differentiate. Well done. We have to differentiate. Okay, so when question asks the derivative means you have to differentiate. Differentiate. Okay. So differentiation, guys, you already learned differentiation in your secondary school, start form 4, and then in your matriculations, right? If you took form 6, you learn differentiation in form 6. Okay, so please, for those who are weak in differentiation, please recall back. You buat sikit latihan lah, you carilah dalam, you boleh Google exercises of differentiation. You have to recall back. Because actually in applied calculus, we will have a lot of differentiation and integration. Okay, so kalau you lemah differentiation and integration, the rest pun nanti you akan lemah lah. Okay, so kalau you rasa you dah lupa, okay, ataupun you memang slow sikit on differentiation, please do some revisions on differentiation and integration. Okay, so now let us solve one by one. Okay, by component lah. Okay, component I, component J dan K. Ni I kan? Ni I, ni J, ni K. So let's do one by one. Okay, so 4t sin t, first component. Differentiate 4t sin t. Macam mana saya nak buat ni? Okay, nak panah. Differentiate 4t sin t. Okay, we have two types of function, right? This is a multiplication of two types of function. Alright, 40, let's say right now, 40, let's say assume this as your u and sin t as your v. So you need to use the product rule. Differentiation, kena guna product rule lah. Okay, so we have u v prime plus v u prime. Okay, so differentiate 40 sin t, we will get equals to u is 40 multiplied by v prime. Differentiate sin, you will get differentiate v tu, differentiate sin, you akan dapat apa? Cos, yes, cos t. Okay, plus v is sin t, so sin t multiplied by differentiate u 40, differentiate 40, we will get what?
Oh.
Yes, so 4. Okay, so untuk komponen I, we have 40 cos t plus 4 sin t. Okay, settle untuk komponen I, baru satu komponen. Okay, second component, 5t squared exponent 3t. 5t squared exponent 3t. Okay, now do we need to use the product rule for this question? Perlu tak guna product rule?
Yes.
Yes, okay, yes, again, yes. Because we have two different types of function. We have polynomial 5t squared multiply with exponent 3t. So again, you use the product rule. So this is your u and this is your v. So samalah product rule u v prime plus v u prime. Macam tadi juga u v prime plus v u prime. So we will have u is 5t squared multiplied by v prime. Differentiate exponent 3t, what should you get?
Exponent 3t over
Over or 3 to bawah ke bawah
times
ke to the left, to the front?
times 3.
Yes, should be 3, right? 3 exponent 3t. Okay, good. Okay, plus v is exponent 3t multiplied by 5t squared. Differentiate, we will get 10t. Yes. Okay, so settle on component J. Component K. Ni senang lah. So differentiate 6 exponent 10t, we will get
60 exponent 10t.
yes, good. 60 exponent 10t. So therefore R prime t, R prime ni maksudnya differentiate lah. Okay, R prime t equals to component by component wise, we have 4t cos t plus 4 sin t, and then 5. Okay, 5 times 3 ni. 5 times 3 we get 15. Ni comma 15 t squared exponent 3t plus 10t exponent 3t. Okay, that is for ij component. And then the last one, 60. So 60 exponent 10t. That's it. Or sometimes students, okay, you also can write like this. Sebab ada certain student dia suka tulis IJK tu, 40 cos t plus 4 sin t, this is I, tambah 15t squared exponent 3t plus 10t exponent 3tj tambah 6t exponent 10tk. So either one lah. You nak buat dalam untuk sharp bracket boleh, you nak buat untuk dalam IJK pun boleh by component Okay. Now, let's take a look at the exercise 2.2. Okay, kita nak sketch parametric curve. Okay, dalam subtopic 2.2 ni guys, this is also important because this will come out in your quiz. Okay, we have tangent vector. Okay, sketching tangent vector. So I will teach you step by step. Sketch tangent vector. R prime t. Okay. So we have this. So we choose one question. Okay, let's say question number 1. Allah, terkopi tu saja sekejap I have to erase first baru saya boleh copy. Tak habis lagi. Okay. Sketch the parametric curve. Okay, first of all, you have to sketch the parametric curve and then find and draw the tangent vector. Okay, tangent vector r prime pi over 6. This is your t actually, guys. When you have this type of question, you have to identify this is your t. T equals to pi over 6. So what you should do now, okay, solution. First of all, of course, we need to know this is your x and this is your y. X and y, okay. So x equals to 2 cos t and then y equals to 2 sin t. Okay, so of course, just like chapter 1, we have cos t equals to x over 2 and then sin t equals to y over 2. Okay, so we will have x over 2 squared plus y over 2 squared equals to cos squared t plus sine squared t. Okay, so we know that from chapter 1, this is equivalent to 1, isn't it? And then we have x over 2 squared plus y over 2 squared equals to 1. This is a what, guys? What type of shape is this?
Circle.
Yes, a circle because the values, the denominator are the same. Okay, so we have a circle. Yes, very good. We have a circle. What's the radius?
2.
Yes, r equals to 2. Good, good, very good. So we have this circle. Okay. We have this circle. Here is 2, right here is 2, here is negative 2, here is negative 2. Okay, this is your parametric curve. Baru kita jawab soalan ni. Ini baru parametric curve. Okay, this is your RT. So next kita kena cari R prime. Okay, previously we have R T equivalents to 2 cos T and 2 sin T. Okay, ini daripada soalan lah. And then tangent vector should be R prime T. Okay, so you have to differentiate 2 cos T, we will get, differentiate yang atas ni, 2 cos T, we will get negative 2 sin T. Differentiate 2 sin T, we will get
2 cos.
2 what? 2 cos T, yes, 2 cos T, positive, okay? So now, like what I mentioned earlier, we need to take note with the values of T. Right now, T equals to pi over 6, okay? T equals to pi over 6. So you have to substitute T equals to pi over 6 inside here and here, okay? So we have at T equals to pi over 6, we have R pi over 6 equals to 2 cos pi over 6 and then 2 sine pi over 6. Okay, like that. So we will have pi over 6 is square root 3 over 2 and then 2 sine pi over 6 should be half. So we will have equals to square root 3 and 1. Okay, and then R prime. Cari R prime pula. R prime pi over 6. Okay, R prime pi over 6. R prime tadi negative 2 sine T 2 cos T. So negative 2 sine pi over 6 and then 2 cos pi over 6. So you will get, this is negative 2 sine pi over 6 is 1 over 2 and then 2 cos pi over 6 is square root 3 over 2. So we will have, this one should be negative 1 and then square root 3. Okay, just like that. Okay, now guys, let me take this down here. Copy. We have this, paste. Okay. R pi over 6, R without prime is actually your P naught. Okay, your P naught. Or this actually your R naught vector, R vector R. Okay, so vector R is from square root 3 and 2. Okay, so from here, sekejap saya nak pindahkan ke atas. Kan. Here, paste. paste ke sini. Okay. So now we move. I will use the blue color. Okay. Listen here carefully. This also will come out in your quiz too this week. So start from the origin, guys. Start from the origin. We move to the right. Okay, right, because square root 3. So square root 3 is less than 2, right? Kalau tekan calculator, square root 3 should be equals to 1.73. Okay, 1.73. So it should be less than 2. Okay, should be less than 2. So we have this, move to the right, and then we go up 1. So 1 step should be here. Okay, so the position is here. So this is the vector of R. Okay, vector of R. Understand? Boleh faham, guys?
Yes.
Okay, good. Okay, next. From this position, okay, let's say we call this as P naught. Okay, P, point P or P naught lah. Okay, so in order to sketch the vector, the tangent vector, okay, ini tangent vector this one is your tangent vector. Tangent vector, we start from P naught, titik P tadi. Okay, titik P naught tadi, P naught ni. Alright, kalau tadi we start from origin. Start from origin or 0, 0. Okay, tapi yang ni tangent vector, we start from P naught. Okay, tulis ni guys, salin balik benda ni, senang nanti nak buat balik you ingat. So start from P naught, okay, we have negative 1. We have negative 1, we have square root 3. So negative 1 means we move to the right or left? Right or left? Left, okay, so start from P naught. So kita move to the left, negative 1, and then we go up 1 step. Okay, we go up 1 step pula. We go up square root 3. Okay, we move to the left 1 step. Tapi goes up square root 3 lah. Sepanjang 1.57 tadi tu. Okay, so we will have this. This is the tangent vector R prime T. Ini adalah RT lah, of course. So this is the tangent vector. Okay, understand?
Yes.
Okay, let's try another question. Okay, jom kita buat soal nombor 2 tu. Number 2 is an ellipse, the same thing. Okay, it's an ellipse, but number 2 is also a circle. So sama macam atas lah, cuma dia berada pada pi over 4. Let's do question number 3. Number 3 ni dia lain sikit. Copy. Question number 3, paste. Okay, question number 3 now. Again, this is by using parametric equations in chapter 1. This is x or y. So you will have this x equals to 2 cos t, and then y equals to 3 sin t, and then cos t equals to x over 2, sama lah. Sin t equals to y over 3. So you will get this x over 2 squared plus y over 3 squared equals to 1. So this is a what? Bentuk apa ni guys? Ellipse. Yeah, this is an ellipse. Okay, good. Well done. This is an ellipse. So now kita kena buat apa? Cari RT, cari R prime T kan? So RT is equals to 2 cos t, 3 sin t. So automatically, jom kita buat teruslah. R negative pi over 4 sebab t equals to pi over 4 dalam soalan ni kan? This is your t. Okay, this is your t. T equals to negative pi over 4. So substitute negative pi over 4 straight away. equals to 2 cos negative pi over 4 and then 3 sine negative pi over 4. So 2 negative pi over 4 is 1 over negative should be positive like this. 1 over square root 2. Okay, and this one should be negative and 1 over square root 2 like this. Guys, 1 over square root 2, sebab ada student tanya saya hari tu, cos 1 over square root 2 ni jangan confuse. This is actually 1 over square root 2 adalah sama je dengan square root 2 over 2. Okay, doesn't matter, sama je sebenarnya. If you use your calculator, you will get square root 2 over 2 kan? Macam saya, sebab saya memang hafal, dulu saya, okay, I'm doing my degree in mathematics, so we have to memorize. So I'm memorizing 1 over square root 2. Sebenarnya nilai dia sama je. Okay, so don't get confused lah. Alright, so now we will have equals to 2 over square root 2, negative 3 over square root 2. Okay, so jom next kita kena differentiate. Okay, tangent vector. Ini adalah your P naught kan? This is your P naught. Okay, so tangent vector. We have R prime T. Okay, you have to differentiate 2 cos T. We will get negative 2 sin T, and then 3 sin T, we will get 3 cos T. Okay, like that. So we will have R prime negative pi over 4, negative 2 sin negative pi over 4, and then 3 cos negative pi over 4. So we will have negative becomes positive lah. So 2 multiplied by 1 over square root 2 like this, and this one we have positive also, 3 over square root 2 like this. Okay, so let us plot the tangent. Okay, now this ellipse, the major axis should be on x or y? Y axis. Okay, good. Y axis. So let's say we have this and this. Okay, so let's say this is the ellipse. Here is 2, right here is 3. Okay guys, so now 2 over square root 2, negative 3 over square root 2. So we move to the right or left first? Right or left? First, kita start right. Yes, origin kan, daripada origin. Okay, this one start from origin. Start from 0, 0. Macam nak lukis dia. So start from 0, 0, we move to the right and then we goes down or up? Atas ke bawah?
Atas.
Bawah betul. Bawah sebab apa? Sebab negative. Yes, so we go down. Okay, so this is the vector of R prime, RT, baru RT. Okay. Now, this is our P naught lah. P naught kita coordinate 2 square root over square root 2 or negative 3 over square root 2. Okay, so next, look here, look at your tangent vector. We move to the right or left? Right. Okay, so kita move to the right, kita go,
Right.
This is your P naught. Okay, we move to the right, and then we go up or down? Up, because positive kan? So we goes up. It goes up here. So therefore, this is our vector of R prime T. Ni. Okay. So that's how we sketch the tangent vector. Satu lagi lah soalan, kita ambil soalan yang quadratic. Okay, let's say this question number 4. Asyik circle tengah ni je kan. So question number 4. Let us find the parametric equations. Rectangular equation. So x equals to t, y equals to 1 over 2t squared. Therefore, we will have y equals to 1 over 2 x squared. Okay, so your RT is actually t 1 over 2t squared. And then you are given the values of t is equivalent to 1. So find R1. R1 should be differentiate, R1 is 1 over 2 lah. Okay, now kita cari R prime T pula. R prime T should be differentiate T, we get 1. Differentiate 1 over 2 T squared is T. Right, isn't it? 1 over 2 T squared, yes. Okay, so we will have R prime 1. We have 1 and 1. Okay, very simple. So let us sketch the graph. We have x, we have y, and then okay, ni quadratic graph. Y equals to 1 over 2x squared. So we will have a smile graph like this. Okay, quadratic. Tajam pula saya lukis ni. Macam tu. Okay. So next, 1/2. R1, 1/2. So start from origin. We go to the right one step and then we go half. So let's say this is the vector. Okay, and this is your P or P naught, either one lah. So now we need to sketch this tangent vector. Okay, we need to sketch this tangent vector. So move 1, 1. Okay, again 1 to the right, one step, and then we go up one step. So we have this. Therefore, this is R prime T. Okay, and this is RT. Macam itulah. Okay, so that's how we sketch the tangent vector. Understand, guys?
Yes.
Okay, so kalau keluar soalan quiz boleh jawab. Soalan quiz nanti ABCD je. Make sure you choose the correct vector lah. Okay? Not the other way. Make sure arah direction tu betul lah, upward or downward. Okay, question number 10 or 11 is about integration. Question A should be very simple. Just integrate, but without the limit. Here, we don't have any limit here and here. Okay, let's do question number 11. Question number 11. Okay, tadi kita belajar, tadi kita belajar differentiation kan, but now we will learn about integration. Okay, so we integrate. Okay, saya nak buat satu-satu lah guys. Let's say yang ni saya ambil question 3, question 10A. Nanti saya buat question 11B So question 10A dulu kita buat yang without. Tak boleh juga. Kita buat yang without limit dulu. Copy. Paste. Oh, cannot. Oh, ni tak keluar, tak detect pula. Tak apalah, apa soalan dia tadi? Integration. Kita ambil soalan nombor 11B lah, terus senang. Nanti saya ambil yang soalan initial condition tu. Okay. So question 11B, integration of vector function of vector question 11B. We have integration from 0 until pi over 4 sine 2t, and then cos 2t, and then 2t dt. Okay, so just like differentiation, just like derivative, we will do it by component wise. So guys, we will have, okay, integrate sine 2t, we need to take the coefficient to become the denominator. So differentiate, integrate, okay, sorry, integrate sine dapat apa? 2 tu jadi 1/2 kan? Integrate sine dapat negative atau positive cos?
Negative cos.
Negative cos, okay, good. Negative 1/2 cos 2t. Okay, so substitute. This is for I direction, substitute 0 and pi over 4 by component wise lah. Okay, and then for the component j, we have cos 2t. So differentiate cos 2t, we will have positive. So 1/2 sine 2t. Again, substitute 0 until pi over 4. This is for j component. And then for 2t here. So integrate, we will get 2t squared over 2, right? So we will get t squared lah. So substitute 0 and pi over 4. So k. Right. So becomes negative 1/2 cos 2 times pi over 4 minus negative 1/2 cos 0. Okay, this is for I direction. Plus 1/2 sine 2 times pi over 2 pula, pi over 4. Pi over 4 minus 1/2 sine 2 times 0. Sine 0, 0 lah. And then j plus for k direction. We have pi over 4 squared minus 0. This is for k. So now cos, this is pi over 2, cos pi over 2 is 0. And this is 1. Sin pi over 2 is 1. This is 0. So kita akan dapat jawapan kita adalah 0. Negative becomes positive. So net positive 1/2i. And then we have plus 1/2j. And then we have pi squared over 16k. Alright, pi squared over 16k. So that's the answer lah. That's it. Okay, kita buat one by component. Okay, next kita buat initial value problem. Go to question number 12. Let us do question number 12C. Kita buat yang paling susah sekali. Question 12C. Okay. Okay, you are given R double prime. Okay, kalau you perhatikan, you notice here, this is R double prime. Okay, so R double prime is cos t minus sin t. Alright, so now how do we find R prime? We should integrate R double prime, right? In order to find R prime, kita patut integrate R double prime. So now we need to integrate cos t minus sin t dt. Okay, this is without the limit, tak ada limit without the limit of integration. So we will have first component integrate cos, we will get negative sin t plus C1. Okay, kenapa C1? Because there are no limit here. Tak ada limit pada integration, no limit. So we need to add the constant C1. And then again, differentiate negative sin t. So integrate negative sin t, we will get what? Integrate. Tadi saya integrate cos. Sekarang ni saya nak you integrate negative sin t. Dapat apa?
Cos.
Cos, okay, positive, okay. So we will have cos t plus C2j. Alright. So guys, this is your R prime t. R prime t equals to negative sin t plus C1i plus cos t plus C2j. Okay, how do we find the values of C1 and C2? Macam mana cari values of C1 and C2? Okay, look here. You are given the values. This is the initial value problem. You have this. Okay, you have this. Right, given that R0 is 1i plus 2j. So, okay, given that R0. Oh, sorry. Before that, kita ada R prime. Kita kena tengok R prime lah guys. Kita jangan tengok yang ni. Okay, ni saya padam dulu. Kita sekarang ni R prime kan. So, kita kena tengok yang R prime lah. R prime, yang ni. This one. R prime 0 equals to negative I. So, given that R prime 0 equals to negative I. Okay, so now negative I is actually in other way, we also can write this as negative 1, 0, right? Sama lah. Okay, negative 1i means negative 1, 0 because we don't have j. Okay, so now what we should do is we need to substitute the values of t here with 0. Okay, so gantikan t dekat dalam R prime tu dengan 0. So we will have R prime 0 from above tu. Negative sin 0 plus C1 I plus cos 0 plus C2j. Okay, so negative sin 0 is 0. Alright, so this is 0. Cos 0 is 1. So we will have C1i plus 1 plus C2j. 1 plus C2j. Okay, so we need to compare this. Compare with the given R prime 0. Compare with R prime 0 equals to negative I tadi tu. Okay, so you kena compare ni dengan yang ni. Okay, ini yang kita kira R prime 0. Ini yang kita kira guys. This one. Ni yang kita kira. So, kena compare dengan nilai yang dia bagi. Okay, so if we compare this, tengok by component component I, we have this. Okay, C1 equals to negative 1 lah. Kan? Sebab you compare component I dengan I. Ni C1I dengan I. So, C1 equals to negative 1. How about C2? So 1 plus C2 equals to, ada J tak dalam ni? Tak ada kan? There is no J, so equals to 0. Okay, so therefore C2 is equals to negative 1. Okay, thus ganti balik C1, C2 dalam yang asal. Thus R prime T is equals to, you ganti balik dalam R prime T ni tadi, yang ni. Okay, dalam ni tadi. This one. So we will have negative sin t minus 1i plus cos t minus 1j. Okay, so this is the answer for R prime t. Alright, now kita baru dapat R prime t. Soalan tu nak suruh cari RT. So what happened? How do we find RT? How to do it, guys?
Integrate again.
Yes, integrate again. Integrate again R prime T yang kita dapat tadi ni. Yang tadi just now. So we need to integrate this negative sine T minus 1 I plus cos T minus 1 J dt. Integrate lagi sekali. So integrate negative sine, we will get cos T positive minus T plus C1 again, a new C1. Ini untuk komponen I, and then plus cos T, integrate, you will get positive sign or negative sign. Integrate cos. Takkan dah lupa kok. Sign. Sikit lagi. Ini last question guys. Saya tahu you all tak sabar nak habis ni. Sabar. Sikit lagi. Minum air dulu. Okay, sin T minus T plus C2J. Okay, so now this is our RT. Okay, dah dapat dah RT kita. Okay, however, we need to find the C1 and C2. So we need to look at the given condition. The given condition previously, kita ada this one. R0 equals to I plus 2J. Dia bagi condition given that this. Given that R0 equals to I plus 2J. So what you should do, you kena substitute your T here. You have to substitute with 0 lah. So T equals to 0. So substitute T equals to 0 dekat nilai T yang kita dapat tu, we will have cos 0 minus 0 plus C1I plus sin 0 minus 0 plus C2J. Okay, so we will have R0 equals to, this is your 1, this is 0. So we have 1 minus 0 plus C1, so I plus C2J. So compare dengan yang tadi. Okay guys, you have to compare. So I compare dengan I ni. Okay, so we have 1 plus C1 equals to 1. Therefore, C1 will be equals to 1 plus 1 C1. Saya ada salah.
0.
Equals to 0. Wait a minute guys. Ada salah ke negative sin T? You all akan dapat cos T, betul dah kan? Negative sin T tadi sekejap Integrate cos T. Integrate cos T, you will get negative sin T, betul. Negative sin T, integrate, you will get cos T. Okay, good, betul dah. Integrate differentiate sin. Oh, sorry guys. Integrate cos T, you will get positive sin T. Padam balik yang tadi tu. This is positive sin T kan? Differentiate sin dapat cos, yes. Ni betul dah. So this one here positive sin T, positive sin T 0. So compare C1 still dapat sama. Okay, betul. Negative 1 cos 0, 1 still dapat sama. Okay, doesn't matter. So sini positif guys. Padam negatif tu. Sini positif. So positive sign, integrate, you will get negative cos, right? Sini negative cos. Yes, saya tersilap tadi. So belakang ni dah betul kan? Differentiate sign dapat. Okay, betul. Negative 1 lah here. Should be. So negative 1. Here should be negative. So kat sini pun negatif lah. Of course, negative. So negative. Okay, so C1 should be negative 1 plus 1. So should be 2. Okay. And then C2 is C2. Dekat atas ni ada C2 tak? Okay, C2 here compare dengan C2 kat bawah ni. So we will have C2 equals to 1. Isn't it? Negative 1. Oh, equals to 1 pula dah. Equals to 2 lah. Apalah saya ni. Nampak sangat saya pun dah lapar. Sekejap Okay. So C2 is equals to 2. Sebab you compare dengan 2 ni. J dengan J kan. Ni J compare dengan J. So C2 dapat 2. Faham tak guys?
Faham.
Faham Saya tersilap tadi. C2 equals to 2 lah. Okay, therefore finally RT is equals to negative cos T. You kena gantikan balik nilai C1 tadi ni. Ini kita dapat ini dengan yang ni tadi. C1 dengan C2 dengan nilai ni dengan ni lah. Okay, so finally we will get negative cos T. Negative cos T minus T and then plus C1. C1 is plus 2I plus J sin T minus T. Sin T minus T plus C2. C2 is 2 plus 2J. Sama tak jawapan belakang? Sin T minus T plus 2, negative, positive. Okay, good. Okay. So, that's all for today's. Okay. So, basically guys, you all ada 4 soalan, 4 questions in your quiz. 2 from subtopic 2.1 and 2 from subtopic 2.2 lah. Okay. Alright, so I think that's all for today.